So I shared a screen here. So this is just a lecture. This is from my friend Ryan Abernathy again, that I'm sort of borrowing some materials for this particular course. How do I minimize this? Show some there. There you go. Okay, you're small. That's pretty tiny. So let's make it a bit bigger. Okay, I want to talk about a library in Python called Pandas. Pandas would be one of the reasons why Python is so popular. Like, it's popular in science. Sure, that's great. But science as a number of software developers or number of people doing data science in the world, we scientists are not the major market. Do you remember I talked about a few weeks ago how the business of all this software development works? We as academics are not the market. We don't tend to buy things for $20,000 a seat. The market is companies and market data and banks and finance, right? Those are the people who are spending money because, well, they earn more money per hour, so they want to have the best tools that they can have. Pandas is a library that has just made basically, a spreadsheet, like the first Power App, the killer app, why all offices now have computers on everyone's desks. Spreadsheets was the first killer app, something called VisiCalc, right? You would go and buy this like $5,000 computer so that your people in your company could have access to VisiCalc as a calculator, because it was just awesome. It gave you a whole new way of working. Pandas sort of puts Excel to shame as a way of working. So Pandas is a library or a package within Python. What I want to show you, and I don't know why this link wasn't working, but I'll just sort of go to the blog post here. So this is a couple years old, but Python has been one of the fastest growing programming languages in the world. And here's sort of the data, right? This is an old plot, and if you look at it in 2020, it sort of looks the same. Python started, a few people were using it 10 years ago, but it has just sort of eclipsed everything in terms of the amount of interest and work that's being done on it. Now, why is that, right? The why is that is because of the tools that we're able to use when we start using Python. Why is it so popular? Data science and machine learning, and then academic research, which is sort of what I come from. But data science and machine learning would be the reason this is so popular, and it has to do with the packages that you get access to. And so there's a few. There's Matplotlib, there's NumPy, they're important, okay? Flask and Django are web frameworks, but then there's this one in orange. Can you see it just shooting up exponentially? It tracks the growth of Pandas as a language. Pandas does something awesome. It's the reason people ended up wanting to learn how to do Python. So Pandas is like a super famous open source package in the world, and I'd like to talk about it. Okay, so the exponential growth of Pandas is due to the fact that it just works. And all the stuff we just talked about in terms of opening up CSV files and making tables, wouldn't it be great if there was something that just made it all work together? Pandas is your go-to tool. Okay, so let's just talk about this. So this is a dump from the Pandas website. It basically gives you a way of dealing with tables of information. The word Pandas, I think it's some acronym like panels and something dimensional time series. I don't know what the letters stand for, but it's something like that. It's basically a smart way of doing things that are tabular, the kind of stuff that you would normally do in a CSV file or Microsoft Excel or from a database or some other format all the way through. It was created by a guy named Wes McKinney, and he's got a famous book called Python for Data Analysis, but it's really created a whole community of people. Okay, how do I get it to go? How do I get it to work? Pandas is the library, and because it is used so often, they use the short form of PD all the way through in Pandas. And we'll also talk about some NumPy and Matplotlib as we go along through here. Pandas has sort of two main data types built into it. The first one is the series. A series is a one-dimensional array of data. You could think of it as a single column in a CSV file. You can think of it as a single column in a spreadsheet. The difference between a series and what we talked about earlier as a NumPy array is this concept of an index. Okay, in NumPy arrays, the index is 0, 1, 2, 3, 4, 5. Like it's a number. That's your only way of indexing something. Pandas has a much more rich version of what an index is. So let's create some series, okay? And there's tons of documentation out there on how to work it. But here's some code, right? So let's say you had the list, Ryan, Kyra, and Johnny, or the list 35, 36, 1.8. What you can do is take those two lists and say, these are the values, and these are the index all the way through. And so here's what you would get, and I'll run this so it's real. This thing ages is a Pandas series, okay? So you can see what it's doing is it's printing out Ryan has the value of 35, and Kyra has a value of 36, and Johnny has a value of 1.8. So if you talk about, it sort of looks like and feels a lot like a dictionary, okay? It's got this idea that I can do lookups, right? I can do that kind of stuff. But it also has this idea of rows. It's not a dictionary. There's order to it. There's a first one, a second one, a third one, and a fourth one. It's built into that. Series have a whole bunch of very useful built-in functions all the way through, namely plotting. So if I just take a series and make a plot out of it, it will make a plot that could be really useful to look at. I want to see how Ryan and Kyra compare to Johnny, and so I can just say, I want a bar chart. There are other default charts built in there. By default, it assumes you want a line chart, but this is just syntactic sugar around matplotlib, but just takes that data and plots it right away. So if you've got some data and you want to make a quick, dirty plot like you would normally do in Excel, you can do this already. Python series work a lot like NumPy arrays in the sense that you can take a Python series and do mathematics on it, and what you get back out is a series, okay? So if I take ages, which is this construct called a Python series, it's got indexed labels and values, I can do math on it. I can take the logarithm of it and divide it by the square of itself, and what I get back out is another data frame. So transformed ages is a thing. So if once I've done that, I could do transform ages.plot, and then we'll do another bar chart just to see what you get, right? Okay, so I've manipulated it in some way. And the benefit here is I haven't had to worry about the index, Ryan, Kyra, and Johnny. It wasn't the first, second, third person. The names are all in there. To get at the index, what you do is you use the lookup dot index all the way through. You could look up a particular value. Now, I gave you the lookup. This is sort of a short form, Johnny, right? But lock is sort of the actual method that you probably should be using. So this is the location in the table or the location in the series associated with this value. Again, you can also talk about the position. So if you don't want to talk about the location, you want to talk about the third row, you can also use ilock. So this is really getting the fact that ages as a thing has a concept of length. Okay, there are 3 things in there. Unlike a dictionary where there's no order, there's order. There's the first name, the second name, the third name. You can reorder whether or not you want Ryan to be on the left or Johnny to be on the right or vice versa. So lock is the keyword location of the data associated with the index. ilock is the numerical indices. If you ever want to back out the actual values, that's what ages.values is. So ages.values is the data, ages.index is the index, and together they form what's called a Pandas data frame. And that's sort of what a Pandas data frame is. It's an array and an index bundled together. The next step of abstraction with respect to Pandas is something called a data frame. A data frame is when you take multiple series and put them all together. So a data frame is a bunch of series that share the same index. It's like a table in a spreadsheet or a table in a database. So here is one way of creating a data frame. I can have a bunch of keys and values, keys and values, keys and values. So one method of creating a data frame is to pass in a dictionary, right? So I pass in something. This is the data where these become the column names and these become the values, and this becomes the index. Almost very commonly, a data frame, which is what this thing is, we use the short form DF if you just wanted to have a generic data frame. You know, when you're doing mathematics and we want to like teach you about algebra and you just need a general variable and you're like, let x equals 4. And we use x just as that standard representation of some numerical value. Or f is the typical symbol we give to just any old mathematical function, right? F is a mathematical function. DF is the variable name that they give to just any old data frame. So if you want a throwaway variable, you just want to like, oh, it's a data frame. It's the data I'm dealing with. We typically give it the letters DF to make it clear to the user, to the end user, this thing's a data frame. Now, right away, DF is pretty cool in the sense that for data frames, it formats this in sort of a nice way right out of the box, okay? I want to distinguish that, right? So if I just kept with data, right, this doesn't look so pretty. I would have to write a make report, loop through the headers. I have to do exactly what you did with the report.py. I have to write a piece of code to make this look pretty. With data frames, it sort of looks perfectly functional right away. I could drop that into a report and it would be okay. It's bolded the index, it's bolded the colors, it's used a decent font. It just sort of comes out of the box. It's a nice way of representing this data which may come through. And it's doing some nice little user interface stuff. If I happen to be doing this in Python, in Jupyter, I hover over and it's sort of, I'm seeing the columns being highlighted. So, you know, it's not bad for displaying this kind of information. Pandas also understands the idea of doing summary information really well. So what you can do is you can say, you know what, take that whole data frame and tell me a little bit about it, right? So right away, it's like, look, I can tell you some things about it. There are 3 columns, an age column, a height column, and a weight column. I can tell you how many values in the column are not null, not empty, and what data type it is. This is taking up 96 bytes of memory. If this data structure wasn't 3 by 3, but it was 30 by 6,000, asking that question of how much memory is it, how many values are in every row. When you're doing exploratory data analysis, this is something you may want to do. You may want to be like, well, what kind of data am I dealing with? How many values do I have that are not empty? I can get that really quickly looking at a data frame. You can also do operations on that data frame. Let's say I had this data frame and what I wanted was the smallest value in each of the age and the height and the weight, okay? Well, I can say df.mean, and what that will do is, or df.min, and it will look through each of these columns and pick the smallest number, and it handles missing data very well, right? So even though that there is a nan right here, it assumes that when you're talking about minimums, you really want to just ignore all the minimums. I want to contrast this to something we saw in NumPy, right? So if I had a data, and I had that same data, 72.5, and then a nan, and then 11.3. Okay, so let's say I was doing this purely with NumPy. Okay, NumPy has a min function as well. Okay, but the minimum of 3 things, where one of the things is not valid, will be not a number because I don't know the value of this thing. And we learned that in NumPy, the solution is you use a masked array to first blank out this one and then call this operation. It can be done, but it's just so much more convenient that Pandas is giving you the thing that you probably wanted anyways right out of the box. Likewise, it can do means, it can do standard deviations of all the columns, but here's the one that I love the best, describe. You got a big data set, you just need a bird's eye view of what it is. What describe does is it takes all of the columns that are numerical and tells you the kinds of things that everyone wants to know. How many values are there? What's their mean? What's their standard deviation? What's their minimum? And then give me some sense of the distribution of the numbers, right? If I just give you a mean and a min and a max, I'm not really telling you the shape of the numbers. Well, now I am. Now you can sort of see, and you got to sort of put your eyes to the side here. Think of this like a histogram, right? The smallest value is 0.15. The 25 The 25% percentile, if you imagine going through it, would be about 18. The 50th percentile would be 35. The 75th, 75.5, and the maximum would be 36.0. You can see right away that this is not uniformly distributed between 1 and 36. It's definitely moved over to the center. It's skewed towards larger ages, right? And we can see that right away with the actual data, right? You've got two people who are 35 and 36, and someone which is only like under 2. So that data is visible. But again, if there was hundreds of values, you wouldn't be able to see that right away. I can always get out of a data frame a particular column. And this is where this notation comes in. So this will bring out for me the value, all the series that corresponds to that column. So if I have a height column, I can bring it out using this. If this name is a legitimate Python identifier, that is, it's all characters and no spaces, what I can do is I can actually use it as an attribute syntax all the way through. New columns in Pandas can be generated by manipulating the existing columns. What I can do, and it's very similar to how a dictionary would work, I can create up a new column called density by just creating the weight divided by the height. And immediately, I've got a new column in my data frame. So DF is the thing you're passing around. It's this data structure, which is very, very rich. These data structures is something you could manipulate and add data to. Let's talk a little bit about merging data for a moment. So if I take a data frame, okay, which I already have. So this DF is this data frame right here. And let me add in a bit more data, okay? So let's say I've gone and I have a different piece of information and I'm able to know what Ryan and Kyra and Johnny and Takaya are all taking in terms of their degrees. I can take that piece of information and create a new series. Okay, so this is another way of creating a series. I'm giving you the values, the index, and I'm giving a name to that column. What I can do is I can join that data frame or join that series to that existing data frame. Now, here's where we're getting the power here of Pandas. Even though in the original data frame, this name did not appear, that's okay. So even though that wasn't there, what it did is it said, oh, you know what? I'm only going to join the data for indexes that you already had. So I passed it a lot of data, and it did a join, which is a database operation, where it pulled out the value for Ryan, for Kyra, and for Johnny. Okay, PhD, PhD, none. But this piece of data, because it didn't exist in the table, it just threw it away. No errors, no warnings, no problems. And that might be what you want. Alternatively, you may say, you know what, I want to join these two data sets together, but I want to do a right join, not a left join. I want to keep all the values here and join them to this table. So for each one of these names, figure out the age, the height, the weight, and the density of all of those values. Well, it does that just fine for Ryan, Kyra, and Johnny. And for Takaya, it knows the masters, but it doesn't know this data. So it just fills it in with not a number. I don't know what the value is. And it does this without complaint. Now, if I was to go along here and change the index, okay, and I was to say, okay, I want to use this one, this one, this one, and this one, I could actually add a new row that have no data at all. I could go and I could change the data so that I'm dealing with a data frame. And if I add in new indexes that don't exist, it'll just create new empty rows without complaining, without having to do anything crazy. This idea of joining is the same idea that you would get in a language like SQL. So on the chat, Dylan asked, is Pandas better than SQL, or does it depend what you use either one for? They're different. They're not the same thing. SQL and databases is a way of storing data. We use a language called SQL or SQL, Structured Query Language, to get data out of it. Database engines are able to do fairly sophisticated reductions of the data, things like joins and filters and wheres. And they're a good way of getting a data set. Now let's imagine you've gone to your favorite database, MySQL, Oracle, Postgres, whatever you like to use, and you've done this query. And you've done this query of the database, and it's giving you back all these rows and all these columns. Now you want to do something with it. That's where Pandas fits in. Pandas is able to go and talk to a database and give you back as results a data frame. The data frame, you can think of it as being the result of a query all the way through. So I would think of Pandas as sitting on top of an SQL database. It doesn't replace it at all. It's a way of manipulating what you get out of a relational database. There's no table, like you can sort of construct a relational database in the sense that you could have two tables and you could do a join like you would in SQL, but there's no foreign keys or any way of guaranteeing certain structures and things that you get in SQL. See, SQL solves a different problem. Could we simply transfer the CSV files to data frames in Pandas? Yes, yes, you're jumping ahead on me. That's exactly what we're gonna do. We're gonna take a CSV file, a bunch of columns of data, and open it up into a Pandas frame, precisely. Once we have a data frame, we can do basic querying on it. I could say, give me everybody whose age is bigger than 18, and I get a subset of that data frame. Or what I could do is I could actually make a new variable, which is a flag, right? And so I could quickly go through my data set and figure out who's true and who's false. Now, Pandas has a lot of built-in plotting, and that built-in plotting just sits on top of matplotlib, right? So if I just give you some data and I say, you know what, I want a scatter plot where the X column is age and the Y column is thing, this just works out of the box. And so you pass in a data frame and it will represent that plot, and the user interface for plot, that is the data frames plot, is fairly robust. So there's a link right here in terms of, let's take a look at what can be done. Visualization, there's a bunch of documentation on how to use it, what can be done, and all the other kinds of plots that are built in, bar charts, histograms, density plots, areas, hex bins, pie charts, whatever you like to use. Right, so like, you know, here is a plot of all the data by bar chart, and you know, pi requires a Y column or subplots equals true. Sure, subplots equals true. It's a bit tiny, but you know, that's fine. Split figure, fig size. Is that going to work? No, you can't do a context on a figure.
I think you need to call I am sure some before.
I am sure there is some way of doing that so I can make it bigger, but entirely possible that I could just pass in a fig size right into that, but I can. I just need to pass the fig size as an option. Really, anything that I can think about doing, it probably can be done automatically, and we're getting better. Let's go 16 by 16. There we go. Okay, so we have 4 pie charts: an age, height, weight, density. Okay, and what we've done is we've taken those columns right away. So the point being, right out of the box, like without having to do any line information, we're very quickly able to get our data and then these basic visualizations very quickly. I would contend that to get this data into something like Excel would take about the same amount of effort. But as soon as you got into plotting, and I don't know how much you've used Excel, yes, I know you can go like insert, chart, pie, define the things. But if I wanted the 4 pie charts right away, to do that in one line, this is pretty powerful, especially if this is just a throwaway plot. All you want to do is see the distribution of how all these things work. It's pretty cool to be able to get this right away. It's put in a label, it's put in everything, it's labeled the different parts of the pie chart. Like, it's nice that it's all in there. And there's tons of stuff built into visualization. Pandas itself isn't the visualization library, but it's got a nice, robust way of calling these lower level visualization toolkits automatically. Okay. Pandas as a, now I guess the other thing is I should say, I don't know if I'm going to talk about it later on. Pandas doesn't require you to use its inbuilt plotting, right? If I wanted to do my own plot, I could always plot the index on one side and the ages on the other. Age, right? I could always make my own plot with matplotlib. This is exactly what y equals age. This is doing what this does, right? All the way through. The only thing is it does a little bit more syntactic sugar. It assumes you probably want a legend. I'll just give that to you by automatically. There's nothing stopping you from using your own favorite plotting library or visualization if you want. It's just often Pandas sort of does what you wanted anyways out of the box, so it can be useful. Anyways, so all the stuff you know about matplotlib still works. You can just do more. In terms of the areas where Pandas has shown its greatest strength, it's been in time indices. So one of the reasons Panda is so popular is its ability to handle as an index time. Okay, so often when you're dealing with a series of data, the kind of series you're dealing with is called time series. So some value of something which changes over time. So here is an example of an index that you can do inside of Pandas. Say I want all the dates from the 1st of 2014 to the beginning of 2016, and I want a daily frequency. That is, I want all of the dates, 1st, 2nd, 3rd, 4th, 5th, 6th, all the way through. This will do it. And then what I can do is I can make another function and actually use NumPy to fill it in. So my function might be sine of 2 times pi to day of year divided by 365. And then the index would be 2 years, and I could plot it. Okay. I want you to think about this for a second, about the complexity of doing this outside of something like Pandas, right? So say I wanted to make this particular plot and I didn't want to use Pandas, okay? So you could begin to do something like a range, and you're like, okay, I want to go from, well, I want to go from year 0 to, well, I want to 2 years, 365 times 2. Okay, y is equal to np sine of 2 times np dot p times x, because that's the number of years divided by the period, 365. Okay, plit dot plot x comma y. Okay, I got the picture, right? That didn't take too long, right? You could do this, but here's what Pandas is giving you that would be as annoying as anything to do on your own. It's part on the bottom, right? This is a time series. It's supposed to oscillate in time. Like this might be a seasonal cycle. Because it understands time series actually as having dates, and it was able to do that mathematics on the dates themselves, we get that date ticker built in automatically. Okay, so if I actually give you a show what time series looks like, okay, time series, its index are dates, and then it has values. This is far more powerful than representing your data just as 2 columns, a column of days and a column of dates all the way through. What you can do is you can use lock to look up the data on particular rows. So I've already told you that we can use time series.lock to look up a particular value. So I could go 2015 0205, right? That's one particular value. But what you can also do is you can do slicing. Now this is looking at 10 days. Better. Oh, sorry. It's a slice operator, right? So this is saying, give me all the rows from February the 5th of 2015 up to February the 15th up to the February 15th, the 5th to 15th of that data. And you can see that what I've used as indexes has actually been the values of the index. What I've used as points. I haven't had to use like 75 colon 150. I was actually able to use the index natively. I can chain these together and actually do something like take a subseries and then plot that all the way through. So say I want to look at a certain amount of data, the January to July period, I could zoom into that data right away. And the way of describing where you're looking in the data set is very natural and very, very simple. If I wanted to turn this into only a 2-month data set, right? I could look at it as a 2-month data set without a problem right away. It's very clear what I'm doing. Okay, let's do this concept. I want to get into looking at some CSV data right now, and we're going to go back to the similar example we talked about before. Let's look at some stock market data. Now, I did sort of play with this a little bit before, and this particular lecture was written a couple of years ago, and so we're going to have a bit of a problem. Okay, stock market data, right? So this is sort of what we've been looking at as our example. It's not domain specific. Hopefully you all know that stocks and equities get traded every day on the markets. And the way that they get traded is people say, I will buy it for this price. I will sell it for that price. Whatever price it actually sells for is the price. But as buyers and sellers change, the price of the asset changes over the course of the day. On any particular day, what you will get is a highest price, a lowest price, and then the price when the market closed, and then how many shares of that equity were actually bought and sold on that particular day on that market. So this particular data was from 2017, and this is what a CSV file would happen to look like. Okay, I want to go through this, and this particular friend of mine, Ryan, created some direct links to help me out, and I could try and run it, and I get some stuff. Okay, and you're like, oh, this is good. This is no problem. I'm going to get some really good data. And at this point, you go, huh? That's not right. That's not what I want. Okay, I want you to make sure you know a little bit about this. You're probably familiar with HTML, right? The language of the web. This is a web page, okay? And buried in here, it says, we're sorry, but your computer network may be sending automated queries. To protect our users, we can't process your request right now. Yes, that's exactly what I'm doing. I'm trying to automate the request. I'm trying to automatically get the data out of Google as a service to tell me the prices of Google, the stock, and Apple, the stock, are over time. This is common. This is the aspect of getting data out. Now, these particular tiny URLs, okay, all that they are is you start seeing things like bit.ly or some sort of short form. All that URL is someone has mapped this phrase to this, and I'll put it out here so you can sort of see it, that link, okay? So this URL is the same as this URL. And this is what's called an API call, an application programming interface function call. This is sort of very much of a REST API type way of doing it. It's just a query. It's going to the website finance.google.com and then passing in an identifier for that stock. So that must be the identifier for Google. Give me the dates from October 1980 up to October 2017. I'm not sure what EI means, and give me the data output as a CSV file, okay? But for whatever reason, that link doesn't appear to be working. Well, if you ever encounter this kind of thing, you might start by going, oh, okay. Does finance.google.com still exist? Maybe they changed where it exists. And you're like, no, oh, okay, I can do this. I can go Goog. Yeah, okay, here we go. Here's the data, right? Let's look at the financials. Let's take a look at this data. I wanna take a look at what it is. Oh, there's the stock price. I want to look over the last 5 years. Yeah, okay. How do I get the data out? How do I download the data? And here we get to the reality of what open data means. Stock data is not open, okay? Google has an economic incentive to show you the data. So I go to their website So I then can look at the ads that they're inevitably going to throw up around me when I start looking at this data. They want me to look at this data on their website. They do not want me to look at this data on Jupyter outside of their platform. They want to keep me on this platform as much as possible. Historically, there used to be a way of downloading this data by an API call, but since like 2017, they turned this thing off. In fact, a lot of places have turned off their free get stock data by an API call because they want you to either A, go to their platform and interact with their website so that I can see ads and things like that. I'm actually surprised I'm not seeing any. Oh, well, disclaimer, buy Google stock. They want me to go to that portal, so they've turned it off. So you can do a little bit of searching about this, and you could say google.finance. No, I should type it incorrectly. Finance.google.com historical, and this is normal, right? You do a little bit of looking up what's going on, and you see some complaints. I'm going to Reddit. That's always dangerous, but we'll find out what we get. Google Finance to remove historical prices? What the hell? The data's still available for now. No, it's not. That was 2 years ago, right? And they've pulled the plug. And if you go and you look at the documentation, what you found is Google has just shut down the public API for this. They want you to buy it from them or buy it from somebody else. They've gotten rid of it. And you go, well, that's okay. I know there are other companies out there that have the data. What if I went to Yahoo? Yahoo's got to have the data. They're like even older than things. Oh, that's not right. I want to see some data. Let's go to Google. No, stop hitting Goog. It's an equity. Okay, same data all the way through, but I'm trying to figure out how to get the historical data. There's a link, historical data. Okay, this is good. This is good. Okay, you know what? I want lots of data. I want like the last 5 years worth of data. Okay, oh, this is pretty cool. Okay, so there's the data, and unlike the Google site, they've given me these as numbers. And at this point, a foolish person would go, I know what I do. I just highlight it all, hit Control Copy, and then I jump it into Excel and I copy and paste and I manipulate it. Let's not do that. Let's learn to never do that, because that's just a big waste of your time. What you are looking for is machine readable data. You want this data in a way that you don't have to copy and paste it, but you want to be able to get at it. So you play around for a little bit, and every site and every kind of data has a different way of doing it, but there's some way of getting at it. And I'm able to notice right here a download button. And I go, oh, that's pretty cool. Can I download the data? Download the data as a CSV. Okay, and lo and behold, I now have a CSV with this data. But here's what I want you to understand. When you click that button, what it's doing is it's doing an API call against the finance server. If I right click on that and I say copy link location, what I'm going to get is I'm going to get this query. Okay, so this query, right, if I was to go to it, what it does is it gives me a CSV file. You see that? It produces that CSV file. It doesn't matter if I use a web browser to do it, or I use a tool like curl to do it. What I'm going to get is I'm going to get the response out of this thing all the way through. Oh, I guess I should turn that into code. So if I run this new version, this new file all the way through, I can sort of figure out what this API call is supposed to be doing. So now let's take a look at what I got. Wait, hold on. Did this not do anything? Oh, come on. This worked in demo time. This is the problem with demos. So let's open up a terminal so we can figure this out. Bad request. Ah, right. Because it's got these funny symbols. There's my data. Okay. So this sometimes it's because in my string I need some quotes around here. There we go. Output that to goog.csv. There we go. That's much better. Okay. So what we've done is we've done some searching and we found a machine readable way of getting that data. There's that data for 5 years. And you can sort of stare at it for a little while and figure out that the period, this is the start, this is the end. Now, what this actually means may require a little bit of figuring. This is an undocumented API. This refers to time codes, right? So I asked for 5 years. So this will probably be 5 years ago and here. My guess is this is the number of like seconds since some time. These are probably time as stored as in seconds. And I've asked for the data as one dimensional. But because I sort of looked at this API call, maybe what I can do is I can figure it out for another equity, AAPL. AAPL, apples. Well, that did something. Let's take a look at what it did. Head AAPL.csv. Data, fantastic. Let's just make sure it's the right kind of data. Yeah, the numbers are different. It's definitely giving me something. Okay, we have now gone in and we have figured out how Yahoo's API works to get some data down. If I wanted to make this reproducible, I wouldn't want someone to have to go to a website, click on some buttons. What I want to give them is something which would always give me the same input back. So I would figure out whatever the magic URL you need to get that data. That is far better than having some instructions that say, go to Google, go to Yahoo, type this in, click this button over here and download the file. This is reproducible. You can do it again and again. I think reproducibility is very important. All that is to say, we've now got a CSV file. Okay, so we've worked with these before, right? So commas all the way through, there's the columns, there's the number. What I can do is I can take that CSV file and I can read it directly into a table. Okay, and it can parse it as a date, an open, a high, a low, a close, an adjusted close, and a volume. I can do slightly better. And my slightly better is to say, you know, that first column, and I'm going to just do this so you can see what's going on here. You see the info? The first column is an object. Okay, so Pandas hasn't been able to quite interpret this. It knows it's a thing that's not a number, but it doesn't know anything else about it other than that. The rest are all been interpreted as floats, and this has been interpreted as an integer. It's figured that all out on its own. What we can do is we can tell Pandas, treat this first column like a date by parsing it into a date. And then I actually want you to use the index as that first column, not all the way through here. And here we go. We've got the open, the high, the low, the close, the adjusted, the volume, and here's the dates for the first so many things. Head is actually something that's built right into CSV files. So we can look at the head, we can look at the tail, we can describe it same way. And the reason we're not looking at the whole thing, because it's 1,200 lines long. It would scroll up and be a lot of data that I need to look at. Again, now the info, right, is a float 64 for the open, the high, the low, the close, the volume, and the index is a date time index. It's figured that out as a function of time. So what I can do is I can look at the closing price of this data, and I can make a plot right away. So this is what the demo had with the other time sequence. Here's mine for the last 5 years, 2016 up and today. That's the pandemic. And it's come back up again. And I have no idea what it's going to do later on. Let's do exactly the same code, though, with something like Apple's stock price for the last 5 years. It reads in the same way, and immediately I'm able to do I could do a plot, but let's do something even better. Let's take the closing price for those two equities and rename the columns. Instead of close, call it Apple. Instead of close, call it Google. And then make a new Pandas data frame that puts them together. So here is the price of Apple and Google as a function of time, and I can right away make a plot, okay? The ability to take data, business data, financial data, academic data, engineering data, whatever, manipulate it and do something and interpret it right away is what's making Pandas really, really powerful. And we can do some things. We can do correlations between them, right? It seems that there's a general upward trend all the way through. So I can do a correlation between the two. And I can see that indeed, Google and Apple, both being tech stocks, are highly correlated. That comes out of the box. But because Pandas is date aware, it can also do things like taking this data, which is daily sample. This is the closing price per day, and I can resample. What I can do is I could sample this data monthly and take the mean over every month and then plot that data. Or I could resample the data annually and then take the mean over each of those years and plot that data annually. And of course, it doesn't work out of the box because line 2D has no property colors. Color. There, they just changed the syntax. Okay, so what we have here is we have the monthly price, okay? And then we have the sort of the 12-month running mean all the way through, right? So this is doing a monthly start and an annual start. It's a mean as of the beginning of that year, rolling backwards, right? There's a lot of different ways of taking these means. These are called grouping operations. You could do it by quarter, right? So let's say I wanted to look at this stuff quarterly, because maybe that in my business, that's what I care about. So here's the stock price on a quarterly basis, and Q for quarterly, as in January, February, March, as one quarter, all the way through. There's a lot of frequency aliases built in all the way through. I invite you to check out the documentation. It understands this idea of time. I'm trying to find frequency aliases. Where did it go? Is it not here? Oh, it's just a giant page. There's a lot. Yeah, these offsets, right? It understands all in time. The other thing that it understands, and this is what makes it pretty impressive, is it understands holidays. You know that, well, let's just take stock prices for a moment. You know that not all years have the same number of days, right? There's leap years. Well, not only are there leap years, but there are also, there's weekends, there's Sundays and Saturdays and Sundays where the market isn't open, but then there are also days within the year where the market isn't trading, right? It's closed for an emergency, for a bank holiday, or for whatever. These dates, these operations will respect the fact that some weeks don't have 5 days in them all the way through. They're aware of these kind of schedules all the way through. Let's do something cooler. Let's take that Google stock and resample it monthly. So take monthly averages, okay? And while we're doing that, what I want is not the mean of every month. So this is what the mean of every month would be. What I want is the standard deviation of every month all the way through. So let's look at how volatile or how much fluctuation the stock did in that month. And lo and behold, the pandemic, the stock price did a lot of changing in that month, right? Because the price went way down and way back up all the way through. Okay, so Pandas, lots of support for financial data. It's one of the reasons it's so popular, but it doesn't have to be used only for financial data. It can also be used for science data, which is where sort of my role comes into it. Okay, so let's look at a completely different data set, and this is some temperatures. Now, the Berkeley Earth data set is somewhere we could go and we could download, I don't want updates, thanks very much, something about the temperature. Let's do global warming, temperature updates. It is a site which is maintaining information about the temperature of the world, right? Air pollution all the way through, results by region. No, I don't want the updates. I don't know. How about, yeah, pick our favorite city. Let's pick St. John's. Let's see if we can find a St. John's. Yes, St. John's, St. Louis, St. ST. There's a lot of names in here. I can do the Control F thing. Oh, come on. You don't have, maybe it's a dot? I don't know. I don't know why St. John's isn't in this list. We're obviously not important enough. Fine, we'll go to Stockholm. We'll go to Stockholm. That's fine. Okay, here's some data, right? And you can see that what this website is doing is giving you a plot all the way through, right? Of the temperature in Stockholm over the last 250 years, right? And because you might be interested in how the temperature is changing as a function of time. You could go and this website is giving you some basic statistics about the data relative to its country, relative to its continent, relative to the global, right? All the way through and giving you some plots. But say you wanted to work with this data yourself, right? You wanted to manipulate it, draw your own plans, put it into a table. Well, it does give you the actual data and it gives you in terms of a trend, okay? So what it's doing is it's downloaded the data for this location on the Earth. And now we see what's really going on is the city is not really what it's looking at, but it's a particular location on the Earth, and it's giving it back as a text file, okay? So this is what you're getting. You're getting the data, right? These are a bunch of comments, and then you're getting all this information about the month, year, month, the monthly anomaly, the 5-year anomaly, the 10-year anomaly, and the 20-year anomaly. Anomaly is the difference between the long-term mean and the current value. And there was a little bit of data in 1745, and then they didn't turn on the thermometers again for a while. They started turning them on in the mid-1750s, 1750s, and it really took until sort of by the late 1700s, they were recording data consistently in Stockholm what the temperature was. You're not going to get data records like this all over the world. There has to have been someone who was going out and measuring the temperature all the way through. Okay, so here is some data all the way through. Let's say I wanted this data myself. Well, again, I don't want to copy it and paste it. I want to make this thing machine readable all the way through. So what I can do is I could take the data. Now this one happens to be for New York City. That's because Ryan Abernathy is based at Columbia University in New York City. So that's what he used. But you could change this to any other region on the Earth. And we could save this data. Okay, so it saves some data for New York City and its temperature data all the way through. Let's take a look at this data, okay? This is not comma separated values data. First of all, there seems to be 3 lines here that you would need to skip. The header is sort of complicatedly stored in 2 lines. There's this blank line. There's no commas. I somehow want to turn 1743 and 11 into a date, and there's all these NaNs all the way through. You could write a piece of Python code, and because of what you did in the previous assignment, I know you are able to write a Python program to read in this file and correctly interpret and calculate out the dates by doing everything we did with parse CSV. But Pandas allows you to do all this stuff with basically no effort. So here's how it's going to work. What we're going to do is we're going to read this file in. Now, Pandas has built into it a function called read CSV. Read CSV is how you would actually read in the CSV file in practice. I would never bother to use your parse CSV. Read CSV does everything yours does and a lot more. So if I do data frame equals read CSV, I'm going to get some errors. I need to help it a little bit. And what it's saying is, the same way that your code is saying, error tokenizing data, expected 1 field and line 5 saw 2. What it was doing was it was looking at the structure and seeing this first line only had 1 line, 1 thing. So it assumed all lines only had 1 thing. And it got to line 5 and went, the pattern's not there. So I need to help it out a little bit. I need to give the pandas just a little bit of advice, of guidance. Well, what I'm going to do is I'm going to say, you know what? I want the column names to be the year, the month, and the monthly anomaly. And then these other 10 columns, I actually don't care what you call them. You can call them nothing, right? It really does not matter at all. I'm not going to end up using them. I want to read it in. I'm going to tell it to ignore the header completely. Don't try and guess a header. I will use my own header, namely column names. I want you to only pull out columns 1, 2, and 3. 1, 2, 3. I want you to use white space as the delimiter. So you know we talked about tabs versus spaces? Pandas understands the idea of blanks. And it doesn't care if it's spaces or multiple spaces or space or tabs or any combination of them. I'm just going to ignore all that stuff. And also tell it, you know, anything beginning with a percentage sign, that's just a comment, ignore it. So if I give this little bit of guidance to Pandas, it is able to right away read out 3 columns of data cleanly. It's now in memory. I've got a data frame called temp. I have to do a little bit of manipulation. I want to take the year and the month, and I want to turn these things into dates. So what I'm going to do is I'm going to take a date data frame, basically taking this data frame, dropping this column off. Okay, I'm going to drop it, ignore it all the way through. I'm going to add in a third column called day. So I have a year, month, and a day. And then I'm going to create a new index of that. So I'll do this in pieces so you can see what's going on. So edit, split cell. Okay. So let's just do that. So you can see that date df.head. No, not data, right? It's just this data frame where I've dropped this column all the way through. Okay. And now what I'm going to do is I'm going to take this column and I'm going to add a new column all the way through. Now, I'm saying it's equal to 1, even though there's lots and lots of rows. Broadcasting rule, similar to NumPy, you're kicking in right here. And it's going to fill in 1 for every value. So now I have a year, month, day all the way through. I can take this data frame and create an index of it by converting a data frame that has a year, a month, and a day column into a date type representation. And that creates something called a date index. So a date index is, whoop, I should spell correctly, is all the dates. But the dates are represented in a type that NumPy understands as having a certain sequence of actual honest to goodness dates. Finally, what I can do is I can create a new temp file by setting the index to date index and then dropping the year and the month. So what I'll be left with, I'll clear all this out because it's sort of old. What I'll be left with is just a single data frame where the date is on this axis and the anomaly is on this axis. And it might make more sense to look at it from the other way around. Right? There's the monthly anomaly, there's the dates all the way through. And because we've got all of the stuff in Pandas built in, what I can do is I can do a temp plot right away. So there is the temperature in New York City as a function of time. And I can do fancier things. I can maybe make some subplots. So I actually have the axis. And I could plot on that plot the actual data, its annual average, and its 10-year average, right? So you can see right away, here is the variability you get month to month. The orange line is the annual average. There's still variability. This is annual variability, it's known. But that green line is starting to see the trend all the way through. If I count these two guys out, you can sort of see the trend all the way through. When we talk about climate change, this is sort of what we're talking about, that the anomaly, well, I don't know how to calculate anomaly. Anomaly relative to what? I guess the long-term mean. I'd have to look into the data on what that actually represents. So I won't say anything else about it. Anyways, so you can do these reductions all the way through. And I want you to think about the sequence of codes we needed to do to get to this point. We needed to, A, download the data. Okay, so we needed to do that step. We needed to transform this data. We needed to load it in. Right? We needed to load that. Oh, whoa, that got big all of a sudden. I didn't want that. We had to load it in. And then we had to do a little bit of manipulation to get the data. Okay? So this sequence is everything we need to be able to plot this data. Well, if we were to go somewhere else now and look at where we're interested in, I don't know, let's try and do that. Lat long of St. John's. Okay, there's some latitude and longitude. That looks pretty good. Right, so I'll just copy that there for a moment for my own, well, not WM. Okay, so 40 degrees. Okay, so let's just try this. Let's see if this works, this API. 56 and to 52.71 St. John temperature. St. John temperature. Oh, it didn't like that one. Okay, so it obviously has specific sequences that it's already chosen and developed. So that API didn't work that way. So we'll need to do some other way of doing it. Come on, let's give something a, okay, if Saskatoon's in there, Sherbrooke, set. Oh, come on. Well, this is obviously oh, largest cities. St. John's isn't big enough. We're not big enough in St. John's. Okay, fine. We'll go to a different city. We'll go to my hometown. Is it big enough? Winnipeg. Winnipeg is big enough. Okay, let's do Winnipeg instead. So that's those locations. Okay. There we go. I'll call this Winnipeg. Winnipeg. Where I grew up. There, I've got the data. I make the plot. Okay. Turns out people weren't taking records in the early part of the year in Manitoba, in Winnipeg, Manitoba. But here's that trajectory all again. The point being, we're able to take data sources, do some analysis to them, like taking a mean, and then make a plot relatively quickly and easily because we're using Pandas to sort of help us migrate the data all around. That's what makes it very, very powerful. We can do time-based sampling and over rolling windows as well, not just fixed windows. So rather than having to take every period of, say, 12 months and take an average, you can do a rolling period all the way through. That's different than a resample. So here is the rolling 365-day difference between the max and min over time for Winnipeg, right? And you can see that the difference in the temperature over a year all the way through. If we wanted to create a climatology, that is what the average temperature is all the way through, what I could do is I could take the temperatures, group it by month, right? So I only want to take the month out of the index all the way through and take the average over each month. So there's ways of doing that kind of stuff. And then you could do other queries saying like, okay, I want you to group everything by the year. Okay, so take all the data, group it into years. Within each year, take the average of all the temperatures. And then within each one of those, sort them by monthly anomaly, ascending from highest down to lowest, and only give me the first 10. Okay, so there we go. In Winnipeg, at least, the monthly anomaly was highest in these years all the way through. There's a 20, there's a 20, there's a 20. There's a few years in the last couple that have popped up in this particular region. Winnipeg is not going to experience the effect of climate change as quickly as some other cities will, at least based on this data. So the point is, using Pandas, you can do these kind of things. If you think back to the first exercise I gave you on using the Unix shell, where I wanted to use cut and sort and shuffle and things, you can do all this in other languages. But the fact that you can do it and get it displayed in a nice sort of way, not bad, what Pandas gives for you. Okay, final little example. Let's go and do something even better. You don't actually need to download a file. What you can do is you can actually pass read CSV a hyperlink, a URL, and it will automatically go get that data, and you can do the parsing all in one go. I haven't tested this one. I hope it's still going to work. Okay, so this is data from the city of New York, and it's giving us information about rats. Well, that's sort of cool. Let's take a look at it. NYC Open Data. These open data platforms are really interesting. Lots and lots of government levels have open data now where they'll give you information, information which is public, and then you can do whatever you want to do with it. And this particular data is, I think it's observations of rat inspections is what it is across the thing, and it tells you what's in it. It's got columns, inspection type, job ID, borough code, all the way through. Here's the data as a table, but what there will always be is some way of exporting the data to CSV. And what I want you to do is not just click on these buttons, but sort of always figure out the right way of getting the data through an API, an application programming environment. So here's what it would be. This link, okay? This link would give you this data as a CSV file, okay? So every one of these sites is going to have some way of downloading the data as a programmatically. And here's what we go. I've now downloaded the data programmatically, and I didn't even save it on the file. I just read it directly into a data frame, and here's what's inside. Okay, it's got all of the different columns: inspection type, job ID, job progress, latitude, longitude, where it was, all the way through. Okay, so I first start by looking at what this data is. Because I said parse dates, inspection date and approved date are being formatted as date time things. Let's just take a look at this data for a moment. Okay, compliance inspections, some IDs, borough codes, zip codes, coordinates. Doesn't actually tell me whether or not they found rats or not. Anyways, let's explore this data set for a while. What we're going to do is we're going to group all these things by inspection type. So I see initial and compliance. Let's count how many there are. Okay. Well, out of all the things in the data, 150,000 were initial checks, and then there were 75,000 compliance checks. I assume they go by. In terms of New York, I guess there's the 5 boroughs of New York, which if we lived in New York, I think we would all know what those 5 boroughs are. I don't live in New York, so I don't know them. You could sort of do that inspection of how many data is there. Let's just look at street names, okay? I'm just gonna look at the street name and count which streets, at which addresses, right? Which streets come up the most often, and count how many there are. And this is actually interesting that it was. 11th Avenue came up the first, and then 20th Lane and 32 Place both came up again. Anyways, we gotta clean this data up to sort of make it more useful. And data cleaning is something that we can use within Pandas. First of all, let's take this data and do some cleaning with it. You see there's some spaces here at the beginning and not on here. This street name data isn't in a way which allows us to look at it well. 72 Road, I don't think that's a proper street name all the way through. So let's do some things. Let's take all the street names, okay, and I'll show you what that is. Rats.street name, and I'll just show the first 2 columns, right? It's these things. What I'm gonna do is I'm gonna take all those data and I'm gonna strip it. I'm gonna ensure that there's no spaces on the beginning or the end of it. And then let's do the same operation again. This is better. This makes a lot more sense. So in terms of a count, First Avenue had 982 observations. One Place had 6. These different addresses all the way through, okay? And these are just the first 10. So I've grouped them, and this is now starting to combine the rows together because all the names at least have the same formatting. Let's do a bit better and group these things by the count, and now sort them in the right way. Okay, here we go. Now this is making a little more sense maybe. You've probably heard of Broadway. Like if you can make it on Broadway, you can make it anywhere. Broadway, New York. Broadway, the street, has had the most of these RAD inspections, followed by the Grand Concourse, Amsterdam Avenue, Webster Avenue, Lafayette Avenue, going down all the way through. But say we didn't know anything about New York, and we wanted to interrogate this data set and figure out where it is. In the data set is this coordinate called latitude and this coordinate called longitude. Well, what we can do is I can just take a look at it for a moment. So let's only look at the latitude and longitude coordinates. And you can see that they go from a min to a max. So latitude is going from 0 all the way up to 40. And the longitude is going from minus 74 up to 0. Okay, clearly there's some crazy outliers, right? New York is not that big. It's big, but it's not that big. It doesn't go from 3 degrees latitude that far south. From 0 degrees latitude or all the way to 0 degrees longitude. Those are outliers. So before we start to work on this data, we may want to clean it out a bit. We look at a map and we go, look, I absolutely know that New York, wherever New York happens to be, it's got to be north of 30 degrees latitude, and it better be west of 70 degrees west, right? All that we're doing here is we are looking only at the data which is valid. A latitude of 0 or a longitude of 0 is meaningless. So we'll do some data cleaning, and now let's do a hex bin. Let's take that data, okay? And this is just the columns latitude and longitude that's been cleaned up. I'm plotting it. I'm plotting a hex bin, which basically will put on the location a hexagon for how big it is. X coordinate and Y coordinate are latitude and longitude. C is the borough code, right? We talked about the 5 boroughs, and then I'm going to use the color map set 1 all the way through. Okay, so right away we start to get some geographical information about what New York City actually looks like, right? I believe this first one, Borough 1, that's Manhattan Island, isn't it? And then if I was any better at New York, I would be able to tell you which one was Queens and which one was Brooklyn. But again, I've never been to New York. I only watched it on TV, so I know these words. But I'm sure someone who's been in New York be like, yep, I recognize exactly where this is. We've got that from the data table right away. What I can do is I can take this data. I'm not even sure what this is supposed to be. Right, so what we're plotting here, no, I don't know what that is. I have no idea what this example is supposed to show. I'm going to skip that for a moment. That worked well. Here's another thing we can do. We can plot longitude and latitude, but the data we're going to show is what are we plotting? What are we plotting in this thing? We're getting a cool plot of something. And we're logarithmically plotting the bins. What are we showing? Valid lat long dot head. Okay, there's all this data. Oh, we're showing the counts. We're just showing the counts is all it's doing. What it's doing is going through all the data, counting how many RAD inspections there were at that latitude and longitude where it's been binned into geographical regions. So what's happening is it's going through this whole thing, not just giving you a dot for where something happens to be, but then bidding them up in such a way that it's counting how many observations there were. So most of these RAD inspections were actually in Manhattan Island all the way through. And it's giving you a color map. The default color map seems to be this green one. We can change the color map to something that's more readable. Right? I'm pretty sure this share X has to do with this issue, which is why it's in there. So on this color scale, we're seeing it, but we still lose all this other data from the other boroughs. Well, one of the ways we can get that back is rather than showing the bins as an absolute count, the number of rat inspections in that region, I could say first take it and do a logarithm of it. There we go. So now on a log scale, there's an observation from the number of rat inspections as geographically all the way through. Right, so this is a much richer exploration of the data than what you could get from the simple table all the way through. Let's zoom into something. Let's only look at borough code number 1, Manhattan. Yay, I got it right. I know what Manhattan is. And zoom into that one little region. You know what? I like my pictures to be bigger. Fig size equals 12 by 12. There we go. Now you're seeing what a hex bin actually is. They're little hexagons, and they're counting the number of observations inside here. This big square in the middle, I'm sure that's Central Park. And amazingly enough, they don't do a lot of rat inspections inside Central Park. But these tell you regions where the rat inspection people have had to come out more often. Let's take a look at time, right? Let's analyze this data by looking at all of the different rat inspection dates and making a plot based on how often these rat inspections actually take place. Okay, so I'll do it right here. This is basically going along and saying, look, I've gone through the data. I've looked at when the inspections actually took place, and I've counted how many occurred on each day of the week, the 1st, 2nd, 3rd, 4th, 5th, 7th, 8th. And lo and behold, rat inspectors work Monday to Friday and very rarely work Sunday. In fact, because the inspection hour is inside the data, I can look at what the typical working hours of a rat inspector is in New York. Seems that they do rat inspections from 8 a.m. to 5 p.m. They might work late, make it early start, but no one does this job in the middle of the night. You're able to tease this information out right away. Finally, let's take a look at the seasonal cycle. Okay, so here are the months, 1 through 12. We see that in winter, they don't do as many rat inspections as they do through the nicer months. I guess there's less, I don't know, maybe people are taking time off, or maybe it's harder to do these inspections in the winter. All of this is to give you sort of a bird's eye view of some of the things you can do with the Pandas package. Pandas is large. This is not supposed to be sufficient. I will direct you to the documentation of Pandas, right? Documentation, user guide, contributing to Pandas. I think the book is open. Yes, he's trying to sell it. That's Wes McKinnon's book. But I was pretty sure that there was a way of getting the book. I'm pretty sure we have access to this book through the library all the way through. That would be a good way of learning about it. There's tons of documentation on it. Take a look. In fact, it's so common that in the help menu of Jupyter, besides NumPy and Matplotlib, Pandas is hyperlinked in there because we use it all the time. Play with it. It's a really good way of taking tabular data, CSV files, databases, and processing and manipulating it. So the way that Pandas work here is there's it's an analysis using Pandas, and what I'm going to do for this one is use the USGS earthquake database. Okay, so this particular database is a way of looking at all of the databases, all of the earthquakes that occur in the world. So similar to the other repositories I've been showing, this is a piece of data which is available and useful for other purposes. There's often a sort of a search form of some kind, right? I can say, give me all of the earthquakes in the last 30 days worldwide. But down here, there's some advanced options and some output options. And you can see the CSV output option, right? So if I say search for this one, what I'm going to get is I'm going to get this query, right? But if you go through and you take a look at how this particular thing works, and I can't remember where the documentation is, but somewhere, what this is really doing is sending you to a link that lets you download this data. It's equivalent to clicking on all these buttons and getting some link for the data, and you can download it so you could do it again and again and again. Taking that data and having some way of reproducibly downloading it again is an important skill. To make it clear, and so there's no ambiguity here, here is a snapshot of that data taken from 2014. It happens to be stored not on the USGS website, but on Columbia University. This is Ryan Abernathy's site, and it just links to it. Take it from here so we're all using the same data for this assignment. But in principle, you should be able to pull that data directly from Earthquakes database as a CSV file. What I want you to do is do some analysis on this. So earthquakes is something we talked about before, but now you're going to do that analysis with Pandas. So going back through either my lecture or other resources you can find on Pandas, again, help Pandas, learn how to use read CSV to open that as a data frame, right? Index this data in a way that the date columns are dates and the earthquake IDs are used as the index, right? Practice using sorting to try and extend out what data is in there. Now, this particular data set has information sorted by where it occurred, and because it's the United States Geographical Survey, sometimes where it occurred is a country, like Mexico or Canada, and sometimes where it occurred is a state, Arizona, New York, New Mexico, whatever. So the data is mixed up, right? There's the country field is either a country or a United States state. And so we have to manipulate the data a little bit to try and figure out when is a state name a state and when is a state name actually a country name. So there is a package here called US, which is probably something you need to know how to install. Pip and Conda are two ways of installing it. It doesn't have to be installed using pip, but I would try that. Try and practice installing software. So try and install the US pip package all the way through. This link will give you to the documentation how to do it. Try and import that US package to see if it works. Then I want you to go to the documentation and actually learn how to use it, right? So the skill here is going to some third-party package, US, the greatest package in the world. Okay, I think it's a little joke. And it's able to deal with state data all the way through, and it's giving you some information. It's saying like, well, this is how you use it all the way through. And that's not a lot of documentation, but it's a little bit of documentation. Read through it, try and figure it out, and use it to write a function, whether or not the string is a US state name, and manipulate this so you actually can get the countries field to actually be countries instead of US states all the way through. So what you're doing is you're manipulating this data set and then filter it for earthquakes magnitude 4 or bigger and create a histogram and make a pretty visualization of it based on where they are and also how deep it is. So this is a typical sort of workflow that you would deal with it. So it's practicing working with data all the way through. I don't think you need to know anything about earthquakes in particular to do it, other than earthquakes happen all over the world and they happen at different depths. And there's this thing called magnitude to register how big they are. Hopefully that's common knowledge. And if it's not, come talk to me if you need a tutorial on earthquakes and I can give you that. But anyways, it's a geoscience sort of data set, but it gets you to practice using Pandas. So go through that all the way through.